Thanks very much. So today I'm going to be talking about some work evaluating LLMs in a Turing test. But first, what is the Turing test? Well, the test was first proposed by Alan Turing in 1950 as an indirect way of asking the question, can machines think? In the test, which he called the imitation game, a human interrogator speaks to a witness via a text-only interface and has to try to determine if they're a human or a machine. A machine witness can be said to have passed the test if the interrogator incorrectly decides that they're a human. Turing thought that the open-ended nature of the game, in which the interrogator could ask about anything from romantic love to mathematics, constituted a broad and ambitious test of intelligence. But why would we want to run a Turing test? Well, Turing's claim that the test measures intelligence is controversial. Some people think that the test is too easy and that humans would be too easily fooled, while others think that it's too chauvinistic and that machines have to imitate human intelligence specifically. So I think it seems pretty clear that the Turing test provides neither necessary nor sufficient evidence for intelligence. But at its core, I think the Turing test tests something potentially more urgent, which is the specific capability for machines to deceive people into thinking that they're human. AI models that can robustly impersonate people could have widespread consequences via social engineering and eroding trust in real human interactions. So it seems like an important capability to be able to track, to understand what contributes to it, and how we can prevent or detect deception. And finally, the Turing test doesn't just evaluate machines. It also reflects back at us our own conception of what it is to be human. So as interrogators devise and refine their questions, they implicitly reveal their own assumptions about what qualities they think are uniquely human and hardest for AI systems to imitate. So large language models like GPT-4 seem well designed for Turing's game in that they produce kind of fluent, naturalistic text. And in fact, there's been lots of speculation that these models, or GPT-4 specifically, would pass the Turing test or already implicitly has. In some of our own work, we ran a kind of crowdsourced, large-scale kind of Turing test. But this work, had a lot of validity issues, particularly kind of a selection bias and not being pre-registered. So here we wanted to run a kind of more experimentally controlled version of the Turing test. So we pre-registered the design and hypotheses, and we used a two-player implementation of the game, which means that there was a single human interrogator, and they spoke to one witness who was either a human or a machine. We recruited 500 participants from Prolific. These were US participants. Each participant just played one game. So the interface was designed to look sort of like a conventional messaging app. So here the interrogator's messages are on the right and the witness's messages on the left in gray. There was a chat input at the bottom, and there was a timer at the top which told participants how long they had left in the game. At the end of the game, the interrogator gave a verdict, which consisted of whether they thought the witness was a human or an AI, their confidence in their judgment, and also their reasoning. So the AI witnesses consisted of a prompt, which instructed them on how to respond to the interrogator's messages. And so the chat history was appended to the prompt, which is sent to the LLM. We use a delay function to stop the LLM from responding at superhuman speeds, and then we send the response back to the interrogator. So here's part of the prompt that we used, which you probably can't read, but to kind of prompt the LM, which contained information about the kind of situation that the model was in, i.e. a Turing test, what sort of personality to adopt. So we told it to kind of be act like a fun young person who's just excited to be having a conversation with random people, and also the kind of tone and style to adopt. So specifically, we told it to be very casual, very concise, and also to type mostly in lowercase and not use much punctuation. So there were 4 different conditions which corresponded to the different types of witnesses that interrogators interacted with. So either human, like other human participants, GPT-4 or GPT-3.5 with this prompt. And we also used Eliza, which is a kind of rules-based chatbot from the 1960s as a performance baseline. So here you can see the kind of aggregate results. So on the left, we have the pass rate, which is the proportion of the time that a witness was judged to be human. And on the right, you can see the directional confidence for each individual judgment. So GPT-4 was judged to be human 54% of the time, meaning that people were not significantly better than you would expect by chance if they were just randomly guessing, deciding whether the model was human or AI. This was also true for GPT-3.5, which was judged to be human 50% of the time. Real human participants were judged to be human 2/3 of the time, so significantly more often than chance. And Eliza had a pass rate of just 22%, so significantly worse than chance. We also looked at whether demographic factors of the interrogator predicted their accuracy. We found no effect of gender, formal education, self-reported knowledge about LLMs, and frequency of interaction with chatbots. We did find a negative effect of age on accuracy, but this wasn't very robust. In order to understand how interrogators were actually conducting these interviews, we tagged the strategies that they were using. So quite a lot of people just engaged in small talk with the witness, asking them details about themselves or what they'd been up to that day, opinions like their favorite pizza topping. A lot of people directly asked the witness if they were a bot or asked them questions about their awareness of aspects of the game itself. Strategies which were most associated with successful identifications included accusing the witness of being a bot, asking questions about logic and math, human experience, and current events. We also tagged the reasons that participants gave for their judgments. So about a third of reasons actually focused on linguistic style. So human judgments tended to cite the witness having a human-like tone or an informal tone, whereas AI verdicts tended to cite the witness being too informal or having a kind of forced persona. And I think some of that aligns with what we're hearing about in the last talk. A lot of people also cited the model having a kind of lack of personality or producing unnatural responses. And notably, relatively few reasons focus on the amount of kind of knowledge or the witness's kind of knowledge and reasoning abilities. So although this study was well controlled in lots of senses, it also still had lots of limitations. So we only looked at a single population, prolific participants. We only used a single prompt, and each participant just did one trial. So we decided to replicate the finding on 100, so these were also US undergrads, so still a pretty weird sample. And each of them did 8 games, and they interacted with different types of witness. So either humans, ELIZA again, or GPT-4 with a variety of different prompts. And we replicated the main finding that these models, when prompted in this way, people are not significantly better than chance at distinguishing them or identifying them as human. In fact, the prompts that we used in the last study, which we called TikTok, was judged to be human significantly more often than chance, and actually numerically more often than real human participants were. But we also found that when we used a kind of minimal prompt with the model that didn't give us this much kind of persona advice, it didn't perform any better than ELIZA, which really highlights the importance of prompting for this kind of phenomenon. So does GPT-4 pass the Turing test? Well, I think it's hard to say. So on the one hand, people were no better than chance at deciding whether the model was a human. And as far as we're aware, that's the first kind of empirical result showing that any system has reached this kind of threshold. However, there's lots of different interpretations and versions of the Turing test, and reasonable people will disagree on what constitutes actually passing. I think more pressing is what these results tell us about how models are passing the Turing test. So rather than kind of impressing interrogators with their knowledge and reasoning abilities, actually they seem to be succeeding by mimicking our social and emotional traits. And I think cast in this way, the Turing test could be reinterpreted as a kind of measure of something like social or emotional manipulation that models seem to be improving at. And finally, lots of participants were reliably deceived into believing that they were speaking to a real human. And counterfeit people, or AI systems that can robustly impersonate people, could have a variety of kind of negative effects, including through things like fraud and social engineering, but also through kind of delegitimizing the real interactions that people have with each other. I'm excited by a variety of future directions for this work, some of which I've already started to look at, including kind of evaluating people on the transcripts, looking at a kind of more rigorous, like 3-party version of the Turing test, which models also seem to be judged to be human kind of more often than not. And also kind of more broadly looking at LLM's abilities for kind of manipulation and deception. Thanks very much to my co-authors, Ishika, Sydney, and Ben, the rest of my collaborators at UC San Diego. I'm also starting a new kind of lab in Stony Brook in the fall, and I'll be recruiting graduate students. So if you know anyone who might be interested in this kind of work, please do ask them to get in contact. And I'd love to hear your questions. Thanks very much.